So, graphs. You guys love graphs, don't you?
Kind of.
No, you don't. We right from the very beginning, we have to be straight up honest with this one. Okay, like so you see maths. Okay, maths is everything is friendly in maths. Okay, it's just numbers and graphs and shapes and algebra, everything like that. And then as soon as you get to chemistry, it all well. How does it feel in your mind? It's very important for me to understand how it feels in your mind when you suddenly see maths in chemistry. So tell me.
I keep saying that that's not chemistry, that's geography. Geography, not chemistry.
So you suddenly see something like a science and you see it with graphs and then you suddenly think, right, okay, that's not chemistry, that's now geography, because geography is more, now that's a really interesting observation actually. Very, very interesting, because with geography then you have like maps and there's a lot of different concepts, a lot of different, it suddenly becomes very, very difficult very quickly. Would you agree with that, Mohammed? What do you think?
Yeah, same thing.
Same thing.
Yeah.
So it just suddenly, so basically, in a nutshell, the chemistry suddenly makes the maths really, really tough. Is that right?
Yes.
Okay. Let's put it this way. How easy is it for you to transfer your skills in maths to the skills that you need to display in chemistry
Easily.
when it comes to mathematics?
Easily.
If it was easy, you would not be finding any difficulty. Are you sure about that?
Not really, because my maths and my level in maths is not really high. So.
Okay. So that changes things around. Okay. So it's like as if you're tied down. You're tied down with your difficulty that you might actually have in maths. And so when you look at maths in chemistry, you then suddenly think, oh, okay, well, I'm obviously not going to do very well on this right now because I'm not very good at maths. Is that what happens?
I think so.
Okay, Mohammed, what do you think?
It's not that easy, but it's good from changing skills.
Okay. Do you think, Mohammed, do you think that you're successful with graphical work in chemistry?
No, I don't
No.
think so.
Okay. Are you successful with graphical work in maths?
Yes, sometimes, not always.
Sometimes. Okay. So you're in a similar position, aren't you? You're like, you look at graphs in chemistry and then you suddenly think, I'm obviously not very good at this right now in maths, and I'm obviously going to find it's very, very difficult in chemistry right from the start as well. Is that the position that you're in?
Yes.
Okay, all right. So what I'm going to do is, first of all, I'm going to make sure that you realize that any hard work that you put into this is going to be like the start. Okay, this is going to be potentially like the way forward for you. But I will try my best to make sure that you do have a good advantage, that you see that all of it is something that cascades very, very quickly and very easily. It is something that's doable, okay? And what I also need to do is I need to share with you as well this section over here, which looks very, very technical. I hope that's on the screen. Can you see mathematical requirements?
Yes.
Okay, this is effectively what Cambridge international exams, what they want you to be able to do. Okay, and there's a lot of maths. This is actually from the specification. Okay, so in there, I will highlight. It says draw charts and graphs from given data. Now we had some green tables, and they could easily turn around to you and they could say, draw a graph from this. Okay, so we definitely need to make sure that we understand that these type of questions are going to come up. Okay, interpret charts and graphs. Okay, so when they give us a graph, we're going to have to work out information from that graph. It's not just going to be, let's put it this way, it's not just going to be, here's a table, you're going to put some plots in there, okay? We actually need to be able to understand and interpret information from that graph. They're not going to give us any clues, okay? Are you with me so far?
Yes.
Okay, then the third thing that they need to do is determine the gradient, and that's the thing that's going to be most relevant in today's lesson, in today's workshop, because the gradient of these rate of reaction graphs tells us an incredibly useful piece of information. It tells us about how, it tells us about the rate of reaction. It gives us a number. It gives us a number. So determining the gradient is important. Now, it's very important for me to say what the gradient is. Effectively, the gradient is the slope, okay? It's the change in maths. It would be the change in the y-axis divided by the change in the x-axis, okay? So what I'm going to do is I'm just going to switch over to the camera to make sure that you figure that out. Hold on. Here we go. So I've got my stuff here, all right? So right from the very get-go, okay? You recognize that in maths, yeah?
Yes.
Cool, right, okay. So the change in y would be that, okay? And the change in x would be that. This looks very comfortable so far, okay? So if you had like a line like that, all you would have to do is just work out change in y, change in x. All familiar?
Yes.
Yeah, it's all familiar, isn't it? Okay, and the gradient, can you remember what the letter is that's given for it? I'll tell you if it isn't, but tell me if you know. So it's y equals something x plus c. Is that what they teach you in maths?
No, not yet.
No? Okay. So you've never met, or you can't recall this? Y equals mx plus c? No? All right. Okay. So y is whatever position you are on the y-axis, okay? M is the gradient, okay? So m is the gradient, x is whatever position you are on the axis, and c would be where it intercepts the y-axis. So for this particular graph, c would actually be this point. So it could be like, I don't know, 0, half, because it's 0 as in 0. And so the coordinate here would be 0, half. So that would be that. And if that was the case, then c would equal a half. Okay? Y equals mx plus c. Lovely folks from BBC Bite Size, how to work out the gradient of a straight line. The gradient is the steepness of a diagonal line and is represented by a number. So it can be uphill in direction or it can be downhill in direction. Gradients can be positive or negative. They don't have to be a whole number, and you can see a very fine example there. We won't play the video right now. But the gradient would be the amount that you go up divided by the amount that you go across. Okay? All right. So how to work out the gradient, all you need to do is work out the difference in height, which is the y coordinates, and divide that by the difference in the width, which is the x coordinates. Okay? There's two examples on the screen. Okay, so anyone that's watching, they can pause those examples. And you can also watch this when you're watching back. How's that? Okay? All right. Good. So that's a very important leap forward. That sounds as if you weren't too sure about gradient. So whenever in a chemistry lesson there's somebody saying the gradient, the slope, rate of reaction, you're suddenly thinking, I didn't know this. I didn't know this. So I think it's very, very clear right from the very beginning that we make sure that you understand what a gradient is. Yeah? Slope, that's a very high gradient, that's a very low gradient, that's a very positive gradient, that's a negative gradient. Okay? All right, okay. So The gradient in chemistry is very important because it actually tells us a really key piece of information. It tells us how fast the reaction is taking place, what's called the rate of reaction, what you may understand as the speed of reaction. But this is where chemistry then takes over, because in chemistry, we also have to track what's happening to the chemicals. With me so far?
Yes, sir.
Yeah. All right. So how we track the rate of reaction, the reaction that you studied in the lesson that I did with you, the reaction was between magnesium and hydrochloric acid. It reacts to form magnesium chloride and hydrogen. In the previous lesson, we learnt that there are 4 ways that we can track this rate of reaction, how quickly this reaction is taking place over time. We could measure the amount of magnesium that's disappearing over time. We could measure the amount of acid that's disappearing over time. We could measure the magnesium chloride that's appearing over time, or we could measure the hydrogen gas that's measuring over time. Now, out of those 4, the one that's easiest to track is the amount of hydrogen. Yes, and you were successful with this when I gave you the questions. So that's why I gave you the questions right at the very beginning. You understood that the gas syringe was able to measure the volume. So the quicker that would fill up, the faster your rate of reaction. Okay. And all you would need to do is track the volume that would be made, divide that by the time, and hey presto, you've got the rate of reaction. Okay, you two seem to be very comfortable with that. Okay, you two seem to be very comfortable with that, and it shows from your results. Okay, so let's see how happy you remain. You were okay, by the way, interpreting the gas syringe. I've got your results in the background, by the way, so I can track what you were good at. Okay. Now, the first thing, so you were okay right until this very moment. You then got to this stage, and you got a table, and you were not able to tell me when the reaction had ended. Okay. So this was the first question that you got wrong. Now, where did we know that Cambridge are going to be asking about this skill? What did we cover in the session today already so far? How do we know that they're going to be asking you about this, about reading from tables rather?
Because they included it in the thing you send us.
Okay, think about the specification. Where do we know? Do you remember the syllabus I just showed you? Okay, so how do we know that Cambridge are going to be asking about taking data from tables? The words that they used, I'll put it in the chat. Okay, so let's have a look. Here it is. So you keep an eye on the chat. Okay, that's what I read from the specification. So, or you can call it the syllabus if you want to. Okay, so how do we know that they are going to ask us to work with these types of results? How do we know? How do we know?
Because they want the gradient.
Yeah, so once we have a graph, that would help us determine the gradient. What about forming the graph in the first place? How do we draw a graph?
So they're asking us because they gave us the typical results. They gave us, so we have to make the graph.
Exactly, Mohammed. Yeah. Can you see how? Yeah, go on. You can say it in your own words.
Me?
Yeah.
Because they give us the results so we can draw a graph.
Excellent. And this is in the specification as well, correct? So you've got draw charts and graphs from given data, interpret charts and graphs. Okay. So there's no surprises here. So we're working on the right thing. Would you agree?
Yes, sir.
Okay.
Good. Excellent. Let's see. The top row says time. Okay. Top row. How much time passes before a reading is taken? That's my first question. 30 seconds. Just Just put your microphone up a little louder, Hamza, so I can hear you. Go on.
30 seconds.
30 seconds. Would you agree, Mohammed?
Yes.
Okay, Mohammed, when is the first reading taken in this experiment?
Just in half second.
Half seconds. Would you agree, Hamza?
Yes, sir. No, sir.
Okay.
It started at
Go
0,
on.
sir.
At 0. 0 what?
0 minutes and 0.
Very good. And you're also using the units as well. Mohammed, you look puzzled, so Hamza's going to explain why.
Because when we the time when it starts at 0. It never starts.
Okay. And what are we measuring? What are we measuring?
The volume of hydrogen in centimeters cubed.
Okay, so what's the reading of the volume of hydrogen in centimeters cubed at the start?
0.
0. Can you see that, Mohammed?
Yes.
Excellent. Because what's the first reading after the volume of hydrogen? What's the first reading after 30 seconds of the volume of hydrogen, Mohammed?
After 30 seconds, it's half. Was it?
After 30 seconds. What's the reading of the volume of hydrogen?
It's half.
Okay. Hamza, we're going to come back to you. Explain why.
The volume of hydrogen is 8 centimeters cubed.
Explain why that is the correct answer. How do you interpret this chart? How do you interpret this chart?
Under 30 seconds.
Okay, it's under the 30 seconds, which is a minute. So I kind of fooled you as well, because I said half a minute. I didn't want to make it, and that's what they will try and do. They'll say half a minute. Of course, you know what half a minute is. It's 30 seconds. All right. And you're going to have to work between units as well. Okay. So give you another chance. After 1 minute, Mohammed, what's the volume of hydrogen that's measured?
14.
14. What do you notice about the numbers? What do you notice about the volume of hydrogen as time passes, Mohammed?
It increased.
Yeah, Hamza's keen. So tell me when that stops happening. So time passes until a certain point where that doesn't become true anymore, or that's not true anymore. So you've said that the volume of hydrogen increases, but there is a point in time where that stops being true.
So in 150 seconds in 5.
150 seconds. Where's 150 seconds?
No,
And
sorry.
5.
You meant 5 minutes. But,
5 minutes.
5
Okay.
minutes.
Okay. Let's all agree to stick to minutes for now. Okay. We're all going to agree. Yeah. Shall we all agree?
Yes, sir.
Okay. All right. Okay. Good. Give me that in minutes then, Mohammed.
5 minutes.
5 minutes. How do you know?
Because it's in the same number, 44.
The same number. What is that number?
40.
Okay, but what is that number? What is 40?
Volume of hydrogen.
Okay, you see what I'm doing here, Hamza and Mohammed? What I'm doing is I'm dancing between the numbers, and what I'm doing is I'm showing you that they are real things that we have to handle as chemists. Okay?
Yes.
All right. So what you're literally doing right now is you're literally interpreting the chart. This is what you need to be able to do. Okay? Are you gaining confidence in this?
Yes, sir.
Good. Yeah, Mohammed? Good. You have to convince me, otherwise I'm going to ask you another question. Why do you think the volume of hydrogen, Mohammed, is staying the same at 5 minutes and upwards?
Because the volume of hydrogen has not changed. So
Okay, but why do you think? Why do you think that's happened?
Because the reaction are finished.
Ah, very good, very good. So there's only one way in which you can make gas, right? There's only one way in which you can make gas. You can only make gas if the reaction's taking place. Okay? So that's a really powerful interpretation. It's a very, very powerful interpretation. Okay? If you have an experiment that's measuring the amount of product, your product here is hydrogen, okay? If you have an experiment that's measuring product produced per unit of time, any number that you have, where it involves a calculation like this, where you have 0 divided by whatever number it is, okay, any calculation that you have, the answer is always going to be 0. 0 divided by that. So, Mohammed has 0 baklavas. He's got to share it between 28 people in the class. How many baklavas is everyone going to get? The answer is 0.
0.
True? Okay, so anything. So the way that you should interpret this now is your rate of reaction is defined by the amount of product, and we're measuring the product in terms of centimeters cubed. So it's the volume of hydrogen. Okay, so in this experiment, it's the volume of product, okay, and it's divided by the time taken. Now you have to be very careful with the time taken, because the time taken may not necessarily be the overall time that has passed in the experiment. And we're going to cross that bridge as well, okay? But the time taken. So if we go back to the graph, we kind of have to think about it being whether it's, we have to actually imagine whether we're actually dealing with local time or the actual time. So over here, with this graph, with this table, I should say, over here with this table, you can see that 30 seconds, half a minute has passed. Can you see that?
Yes, sir.
Okay, so now we can go back to the volume of hydrogen. We can see that 0 centimeters cubed of hydrogen have been produced. So our calculation would be 0 centimeters cubed of hydrogen divided by 30 seconds, or divided by half a minute. Now, what do we know? Is the answer to any calculation where you have 0 divided by something. It's always going to be 0, okay? So where you have the volume of hydrogen divided by time, that defines the rate of this reaction. So if the rate of the reaction is 0, for any chemical reaction, you then automatically realize that the reaction has finished, okay? So the rate of reaction is actually something that's very, very powerful to us. As soon as it hits 0, you know that the reaction has finished. It's never going to go backwards. Well, not in this situation, okay? In this situation, this is a very, very nice, friendly reaction. It's always moving forward. You're always getting reactants going to products, okay? There are some chemical reactions that do different things, okay? They actually go backwards. But in this one, it's just moving from reactants, the left-hand side, to the products on the right-hand side. So you're not getting a negative number, okay? That's why in this experiment, we can see, and looking at the graph, you can see that the line kind of, we have to be very careful when we're describing a graph, okay? Very careful, right? And this was a question, this was actually one of the questions that I put in there as well, okay? And I know that you got this one incorrect as well. I'll double check to make sure that it's a precise one. Okay? But we have to be very careful about the language that we use. Now, when we say increasing, you're actually saying two things. Could be one of two things. You're actually either saying that time is increasing because you're moving from left to right in time on the bottom axis, okay? The time is increasing because time only has one direction, okay? We're not going back in time, not back to the future, okay? So you could be saying that. When you say increasing, Mohammed could be understanding that you are talking about time is increasing. Not a problem at all. Yes, Mohammed?
Yes.
Yeah? However, Hamza could also be talking about the plots are going higher and higher and higher, okay? So Mohammed could be thinking it's time, but Hamza could be referring to something else. He could be referring to the volume of hydrogen increasing as time passes in this experiment.
So should I say like the plot of the graph is increasing, and when it reaches a certain point, it continues to stay 14?
Okay, right. So you have to, again, be very, very careful. This comes down to our second point, which is how to interpret the chart and the graph. Because what you could be doing is you could be interpreting it correctly, but you could be writing it down incorrectly. Okay? So so the best thing to do is to refer to the values that they give, the volume of hydrogen, or the time in minutes. Whenever you're talking about numbers, if you want to talk about something that's increasing or decreasing, you're automatically referring to numbers, okay? So always refer to what the number is that you're making reference to, okay? So instead of saying it is increasing, say the volume of hydrogen is increasing. A better quality answer would be that, okay?
Yeah, but also the time is, let's say, like it's both, because it's like it's going at the same time. So for every like 30 seconds, it's the volume of hydrogen is increasing, and the time in minutes at the same time. Like, and when I write it in like down on my book or computer, how can I say like it's the volume of hydrogen and the time of minutes is increasing at the same time?
Okay, so it pretty much depends on what it is that you're actually, and I'm going to transfer over to my drawing now. It pretty much depends on what it is that you actually want to be describing. Okay, the good news is that they will step in. Are you all right, Mohammed? So the good news is that they will always step in and they will always guide you at this point. Okay. So you don't have to worry about the computer, but that's where you then have to read the question. You have to read very specifically what it is that they want you to be talking about. Okay? All right? So that's the good news.